Okay, I guess we're live. Assalamu alaikum, everybody, and welcome to the live webinar session of the Bachelor's of Science in Robotics. It's a new degree program that is being launched by all 5 campuses of National University of Computer and Emerging Sciences, commonly known as FAST NU. Today, my name is Umar Salim, and I'm currently serving as an assistant professor at the Department of Electrical Engineering in FAST NU Lahore campus. And today I would be discussing with you and interacting with you, all of you, regarding the insights, various insights related to BS in robotics on behalf of Lahore campus. I am joined here today with Dr. Kashif Saeed. He's currently spearheading the BS in robotics program from our department. And we have also been graced with the presence of Dr. S.M. Sajid, who is currently serving as the Dean of Engineering at the Dean of the Faculty of Engineering at FAST NU Lahore. So Dr. Sajid, a brief introduction about him. Dr. Sajid has a PhD in optical communications from Austria. Dr. Kashif has his PhD in robotics and mechatronics from France. Thank you very much, Dr. Saab, for being here with us today. Before I officially start this session and interact with all of my audience out there, I would first of all like to give this podium to Dr. Sajid. I would really appreciate if he could open this session for us and grace us with some kind words, some insightful thoughts related to this program. So Dr. Sajid, please.
Bismillahirrahmanirrahim. Welcome everyone. This is a kind of introduction to our Bachelor of Science in Robotics program. This program has been designed during the last year. We had numerous meetings to look at the curriculum, what should be the courses, what should be the combination, what should be the important ingredients for the program. And we have developed a very comprehensive curriculum for this new program. And this is a very futuristic program. I am very proud to tell you that our university is the first university in Pakistan to have introduced a Bachelor of Science in Robotics program. No other university has offered this program till now. And we have taken this initiative, and we are very hopeful that this program would grow. It would get good students, and inshallah, those students would get very good training with us, and then they would be able to contribute to the society in very meaningful manner. The times are changing, and in these times, the current modern times, we need a situation where we can have interdisciplinary skills and where we can build things and contribute to the knowledge economy. Without that, education nowadays doesn't mean much. And the things are changing at a pace which is so fast that you need to adopt to those changes at a very rapid mode. So what I can tell you is that the curriculum of this program is very well designed. I myself led the design of the curriculum, and it went through all the bodies of the university multiple times. We started with the Board of Studies, and then we went to Board of Faculty, and then to the Academic Council in the winters. Then it again went to the Academic Council in the spring. So it is very well designed, very well thought of, and it shall inshallah be a very good addition to the programs that FAST National University offers. So I leave it here and give it back to Umar. Umar has some more information which should help you.
All right, thank you very much, Dr. Sajid. Really inspiring words. Okay, so I'm going to formally start with a small presentation that I have.
Umar, can you stop for a moment? There is a question.
Sure.
there is a question, what is the aggregate for admission in BS robotics? This you cannot know till the admissions are announced. What I can tell you is that since this is the first admission in robotics, so generally there would be a higher chance for those who apply in robotics to get in. But the what you are asking is basically the threshold. The threshold is decided after all the applicants have taken their admission tests and the calculations have been made that how many have applied and what are their scores. After that, it is decided that what's the threshold. I think I have answered your question.
All right. Thank you, Dr. Saab. Okay, so let's begin. So welcome to FAST-NU. It's a short form for National University of Computer and Emerging Sciences, run by Foundation. Okay, so BS Robotics. Now, the BS Robotics, as Dr. Sajid has rightly said, it's a very innovative BS program that has been designed to cover all the methods used in the designing of robots and specifically intelligent machines. So we're not really restricting ourselves to the robots, also the intelligent machines that operate in the natural environment, in our real-time environment, with no or little human supervision. Okay, so basically we will be developing intelligent and autonomous machines that would be given some artificial intelligence, and those on the basis of some set rules, those machines will perform tasks in the most efficient and the most safest manners. All right. Okay. So in this particular degree program, the main idea of designing this degree program was to equip our students with the ability to conceptualize a robotic system, an automation system, to be able to design it via whether it's simulations, whether it's on a piece of paper, or whether it's a concept in a, they should be able to design a particular automation system or a robotic system. Now, if you see that robotic systems are extensively used in industrial automation environment, and one such animated snapshot is right on your screen. Now, once they are capable of designing that particular setup, automation setup, then comes the task of development. Now, what kind of architecture they would be needing for it, what kind of hardware they would be required, what kind of software would be needed, and how could those two things be integrated. So that comes in development. And once the development phase is over, then is the deployment. This is going to be our main focus. In this degree program, we would like to, or we would hope to equip our students with these three key skills. And you can say these are sort of the learning outcomes as well. They should be equipped with the ability to design, the ability to deploy, ability to develop in that same order as written, a particular robotic system to perform a given task intelligently, autonomously, efficiently. Okay, so this is the intended objective of this degree program. This was the sort of what we hope to achieve. Now, why should anybody choose robotics? Now, there are many fields out there, and with the rapid advancement, so many fields have branched out. If you look at the Forbes list of upcoming emerging careers, or the Bureau of Labor Statistics in US, you will come up, they will be telling you several career opportunities. Several careers have been branched out, and many of them will be becoming the top scoring, top earning careers by 2025. Why choose robotics? Now, the thing is that definitely the introduction of robot in an industrial environment, in any environment, definitely increases the operational efficiency, the efficiency of performing a particular task of a particular operation. Okay, with the ability, with the introduction of robotics, we can efficiently perform tasks that are otherwise very dangerous for human beings to undertake on their own. All right. And in some cases, it's not even about the efficiency or the safety, it's more about the precision that you can achieve with the help of a robot. Okay, of course, definitely you can never compete with the human skill, but in some cases, the intricate surgical procedures that can be done with the help of a robot are far much superior. In case of IC or chip designing, the integrated circuit designing, robots and mechatronics has played a groundbreaking part. Okay, so this is one of the few reasons why you should choose robotics, because definitely robots are already revolutionizing the industry. जिसे आप कहते हैं Industrial Revolution 4.0, the robotics or the robotic systems make a big chunk of that revolution. All right, and definitely with the further advancement in the field of science and technology, this percentage, the involvement of robots in the industries, in our day-to-day environment, is going to only increase. And definitely, if that is going to increase, we would need professionals which are able to troubleshoot these systems, which are able to handle these systems, design these systems, program these systems, maintain these systems. And with that comes more employment opportunities. Okay. Now, the innovative traits of the BS robotics, which is being offered by FAST NU Lahore. As I've discussed time and again in the past 1 or 2 slides, it's an emerging field. If you take up the upcoming careers from any platform, up LinkedIn pe jaake dekh sakte hain, the upcoming top 10 careers, you will always find robotics among other careers such as biomedicine hai, biotechnology hai, data analytics hai, Internet of Things hai. Amongst these buzzwords, amongst these names, you will always find the name of robotics. Roboticists are definitely going to be in a huge need, locally as well as in the global market. And I will come to this point afterwards. Global acceptability. Now, a degree, having a applied sciences degree in robotics is definitely increase your portfolio. You will be globally acceptable because it's a very emerging field, and definitely your employers, whether they are local or foreign, they would definitely run to, get you on board. As Dr. Sajid already has have mentioned, that this degree is first of its kind in Pakistan. Now, there are many premier universities in Pakistan who are already, have or are offering an MS degree in robotics or an associated field, but FAST NU Lahore has taken the initiative to be the first university in Pakistan to actually start a Bachelor's of Science degree in robotics. Okay. It's an interdisciplinary program. I will discuss this point in a very detail in one of the upcoming slides, and it's going to be very interesting. This degree program has been designed by keeping in mind that we want to equip our students with skills coming from different domains. If I would like to give you a small trailer of it, the BS Robotics program combines all the domains of electrical and electronics, mechanics and mechanisms, which is a whole different field, computing side. And when we talk about computing side, even that is a very diverse field now. We're talking about programming fundamentals, we're talking about artificial intelligence and learning algorithms, we're talking about algorithm analysis and design. So even that would be involved in this particular degree. And then, of course, the basis of any scientific degree is mathematics. We would also include a number of courses in mathematics. So by the end of the degree, you will have the knowledge of all of these said fields that I've already mentioned. Okay, hands-on practice. Now, this is another main objective. While we were designing the course outline, and Dr. Sajid and Dr. Kashif were very adamant about that we need to come up with a degree program that would equip our students with hands-on skills, that they should be able to not only simulate or design a system on a piece of paper, but they should actually be able to go out there and deploy it physically, whether it's development of a circuit, whether it's development of a software, whether it's the integration of the hardware with the software. They should be able to see something physically working in real time. They should be able to develop a mechanism. That mechanism should be programmed in a seamless manner. So this degree program has several modules specifically designed to harness the psychomotor abilities. That's a good word I would use, psychomotor abilities of the students. And if I would tell you that in every spring semester, normally a degree program has 2 semesters in a year, the fall semester and the spring semester. So in this degree program, in every spring semester, we have included a standalone lab, a robotics design lab module. And that lab would go on in a very methodical fashion. So in the first year, that lab would be very preliminary. Based on that knowledge in the second year, spring semester, that lab will be evolved slightly and a bigger problem statement would be given. Then in the third year, in the spring semester, the robot design lab would be even more bigger than the previous years. And so in every year, by the end of the year, a problem statement would be given to the students and they would be required to implement that particular robotic system, whether it's a software module or the hardware module or the integration of the two, to be and show. And based on these first 3 years, the output of these first 3 years, the students will then be required to take up on their final year project. So definitely it will be bigger than the first 3 years. And this will also be a test of knowledge of what they have studied in the whole year. Local and global job market. Now, definitely, this is one of the bigger concerns. Whenever you start in a new degree program, the first question that comes to your mind that would this be a degree, no matter how interesting it sounds, whether there would be a job market for it. So by the time I'll be done with this presentation, I think you will get an idea that, yes, there is no point problem in you getting an employability, in getting employed after this, getting this degree. And now we're not only targeting the local job market, that is not an issue. We are also targeting the global job market. Pakistan is in its infancy in field of robotics and everything, but globally the robotics has penetrated almost in every industry, whether it's chip designing, IC manufacturing, assembly line, large scale manufacturing, precision manufacturing. In every industry, robotics has penetrated intensively. And so we are coming up, we have developed a degree program which will not only target the local market, but would also help our students to target the global job market as well. And this thing, this whole thought process has had years of market research behind it. We have been, our electrical engineering department is already very mature. We have been offering this degree, electrical engineering degree program for several years, and many of our graduates are settled in high profile multinational firms. And they come back to us whenever we get an alumni council meeting, they come back to us and they discuss with us their current needs. And based on that, based on the summaries of what they tell us, the industrial requirements, this degree program fulfills. I'm proud to say that this degree program hopes to fulfill all those gaps. Okay, now this is the point which I was talking about, the transdisciplinary field, which was the fourth point, and I said I will have a whole slide on it. Now, this particular degree program has been established keeping in view the 4 basic pillars. Okay, any robotic system, if you want to develop, would always require a combination of all these 4 fields. The first is the mathematics. Mathematics is basically at the foundation of every scientific area. So definitely in this particular degree program, we are going to be extensively studying several mathematical courses. Then a big chunk of this degree program is composed of electronics and electrical knowledge. You will definitely be taught extensive concepts related to electronics, instrumentation, electrical networks, and stuff like that, because that becomes a critical part of robot circuitry that helps the robotic motors to move and everything. Then the computer sciences. And again, I would say the computer sciences is a very broad term. Even the computer science has been, dissociated into several sub domains. So there is one particular domain which deals with the programming fundamentals. So we will be extensively teaching our students to be able to learn and code a computer program in the languages, in many of the languages. Okay, having done that, our next domain, subdomain of computer sciences that we will be specifically targeting is artificial intelligence, because a robot would definitely need a synthetic intelligence, would need some induced artificial intelligence, so it could be able to make decisions in real time. And that portion will be covered with the help of artificial intelligence and machine learning. And then, of course, the algorithms, the movement of the robot, all of these, this requires some kind of an algorithm. And that is, again, another subdomain of computer sciences. So all of these areas. And it's not going to be a single course. No, there are going to be multiple courses which eventually would lead up to the conclusion of this domain. And then finally, a robot is a moving object which has a lot of mechanisms working in conjunction with one another. So for that, the graduate needs to be able to know the working of mechanisms, the mechanics of materials. And for that part, we will cover extensively the mechanical part of the things. Combining all of these would help you to eventually make a robot. And I would like to add here that we generally think that robot is something that is moving on wheels, or a drone which is moving on some rotors or something like that. No, any machine, any mechanical moving machine, any machine that can take its decisions independently is a robot. All right. And every intelligent machine will definitely have some electronics in it. It will definitely have some computing portion in it, some microcontrollers, some microprocessors, some computer working as its brain. It will definitely have some moving parts which will be performing the task and interacting with the environment. And all of this will be based on some mathematical equations. Now, how are we going to go for it? So generally in a degree program, there are 4 years, and in these 4 years, the student takes 8 semesters. So in the first 6 semesters, in every semester, we will be teaching one course from the field of mathematics, one course from the field of electronics, one course from the field of computer sciences, one course from the field of mechanics. Now imagine that in the first semester, you will be taking the preliminary of all these 4 domains. Then in the next semester, the post-requisites of all these. So in every semester is composed of one course from each of these domains. And by the time you reach your 6th semester, I think you would have read at least 5 to 6 courses from each of these domains, thus giving you a very good idea of what or how you need to implement the system. Then in the final year, you will be studying hardcore robotics courses, and these will be specialized electives, which could be from the field of biomedical sciences. If you want to gain expertise, they could be from the aeronautics, avionics, industrial side, which could be industrial process control or automation side, software engineering, which basically covers the softwares of robots. Okay. All right. So once you graduate, this is the question, and I think most of you will be interested in that. Once you graduate, how can you work? What will be your job description? So as I've said earlier, that you will get extensive knowledge regarding computer sciences, extensive knowledge regarding electronics, first-hand experience from mechanics and mechanisms of materials. And then definitely mathematics is the root of everything. So you can work definitely as a roboticist in any of the companies, multinational companies. And as a roboticist, you would be required, your job description will include you to be a programmer. As a programmer, your duties would be to design, build, implement, and monitor computer applications or computer programs. You can be system design engineers, where you will be required to make computer-aided designs or implement computer-aided manufacturing systems. Okay, so the system can perform in a very safe and an efficient manner. You will be using specialized softwares, maybe even implementing specialized softwares and tools to design these systems, different aspects of robots. Product testing and maintenance engineers. So once a company deploys a particular robotic system and automation system, definitely robots are used in industries. Robots are extensively used for automations. So definitely they would be requiring maintenance engineers, whether they're in the field or at the software side. They will be required engineers to maintain these operations for the safe working of these operations, so that the assembly line doesn't stop during the operations. Product testing. Once a company who's actually producing these robots, the robots are their products, you will be ensuring the quality, the working authenticity of these robots as product test engineers. You can be working automation field specialist, because with all these courses that you are being taught, you can easily develop an automation system and you can easily work. You can develop computer applications related to robots. Okay, even if you do not go for the field job, then you can always go and seek higher education, and you can start working as a professor, and you can do some R&D. You can get some funding, you can develop your own robotic line, you can contribute to the society by conducting rigorous research and development in the field of robotics, coming up with new, innovative, more cost-effective solutions. You can always pursue the career of project management. So there are many in automation companies which would require a person with the hands-on experience on robots to be able to understand the system and then manage or lead a team that is handling these robotic systems. And of course, there's always this possibility of entrepreneurial ventures. Who knows, maybe you can come up with an idea or a system that could be the next Forbes 500. The job description, and this is basically the summary of what I've already discussed. Job description will generally include the development of computer programs that are efficient for the efficient and safe operations of the automation or computer-aided manufacturing setups, robotic setups, development of the robotic and automation systems, mechanical systems in a very cost-effective manner, development of a safe integrated work environment. And this is human computer or human robot interaction. It's a very important field of robot. You should be able to come up with a robotic system that should be safe for its users, it should be safe for the people around it. Okay, so there should be some SOPs set in place, set of SOPs which are written as meta rules, which could be followed strictly, stringent rules which are to be followed by the robotic system so that the users around it, the labor around it may not get affected. And of course, lastly, troubleshooting these systems in real-time environment, whether they are assembly lines, whether manufacturing lines, whether it's a robotic system in construction or in avionics, any field, whether it's in biomedicine. Okay, definitely having a robotics degree followed by a specialization in biomedicine would put you as a surgical robotic engineer. A doctor would need a surgical robot engineer to perform the surgeries. Okay. Now, this is pretty much what you are going to get in this degree. And where would you go after the graduation? This is something, BS program objectives, this is something that we hope to induce in our students, the skills that we hope that our students would have once they graduate and go out in the field. The first thing is, and again, going to the first point, I would like you to focus on this particular slide. Robotics is basically an amalgamation, a very synergistic collaboration of these, a very beneficial combination of these four fields. Okay. With that, what we hope to achieve is to induce a sense of versatility in our students so that they can practice these engineering skills, these mechanical skills, these electrical skills, these computing skills in a broad range of industries. Learning that they should be able to pursue advances in the education. Okay, I mean, they should be able to itni equip unko kar dein ke they can pursue a specialization degree in computer sciences if they like, or mechanical side of the robots and they like. They can pursue a specialization in the embedded computing side, or they can seek, after this degree, they can also seek a advanced degree in the electronic side of the robot. So versatility, and so they're equipped to pursue any field of higher education which is related to the field of robots. Conduct. So we want to develop graduates which have sound professional skills and ethical skills so that they can perform these, and developing a robotic system requires a lot of ethics. The first and foremost is your system should be cost effective and it should be safe for the users around it. That's where the first test of ethics comes in. Engineering skills, and this is definitely the main concern of any scientific degree, that should be able to, the students should be able to have hands-on problem solving skills. So any technical problem that is given to them, engineering problem is given to them, they are able to solve it for the betterment of the industry, society, or the environment. And whether they are complex problems, and normally the industrial problems are complex. And finally, the leadership. So with all of these first four traits, we want our graduates of BS Robotics to have the ability to lead a team of engineers, robotics engineers or non. They should be able to have sufficient managerial skills to be able to lead a team of professionals for the economic development of the country. Okay. Now, the BS Robotics curriculum, as we have discussed, like every other BS degree, as per the requirements of HEC, the duration of this degree is 4 years, and this is 8 semesters. The total credit hours will be 134, and normally each semester has 15 to 16 working weeks. This makes like 30 to 32 contact hours for every subject in that semester. This is our curriculum composition. A more elaborate breakdown can be shared at a later stage, but of these 134 credit hours, the courses related to robotics form the biggest chunk, and they are 30 credits. The courses related to computing are 27. So you can see how many courses or how much elaborate studies will be imparted to the students. Then the courses related to the field of electronics are 34. Again, electronics and electrical side of the system is extremely important. You make all the circuitry, the embedded side, the microprocessors, you need to wire them up, and you need to be able to connect them with the power source, and they should be able to move. The motors should be able to work in sync with one another. All of this will be taught in the field of electronics when you study it. And then, of course, you are making an object which is moving, different mechanisms are working. So there comes the mechanics part, and it has 10 credits. This is a pretty big chunk. Then mathematics, there are 12 credits specified for mathematics. Humanities, इसमें आपके पास Islamiyat, Pak studies, business writing, technical report writing, professional ethics, इस तरह के courses आते हैं. And I've said this is one of the main learning outcomes, program objectives. So definitely we are giving sufficient chunk to it as well. And then finally the management, in which you will be taught engineering management, operations management, project management, engineering economics, and courses like that. All together, all of these domains will sum up to form the 134 credit hours. And you can see that by the time you graduate, you will have all of these skills, especially focusing on the first 5 skills: the robotics, the computing, the electronics and mechanics and mathematics. And just on a side note, you can work in software houses. You can work in the field of electronics with all these courses taught. You can work in the field of mechanics with all these courses. You will be equipped, sufficiently equipped to work in any industry. So versatility and diversity. The program structure of these degrees. Now, ये वो domains हैं, इनके इस तरह के courses होते हैं, like not specifically these courses, but these are like generic terms. So there will be a number of courses related to engineering mathematics, a lot of courses related to computer programming, different languages, object-oriented programming, design of algorithms, data structures, design of algorithms. I've already said that. Computer-aided design, in this we would be studying the modeling and simulation of a mechanical device or a mechanical object in AutoCAD or SolidWorks, stuff like this. You will be able to draw and maybe even animate a mechanical object. Then comes embedded computing. Now, embedded computers, like your own computer, like your microcontroller, they form the brain of your device, and you should be able to program it. And definitely the number 2, computer program, is directly linked with number 5. If you're good at computer programming, then definitely you will be very good at embedded computing. Okay, modeling and simulation, this can be hooked up with computer-aided design, computer-aided analysis. Artificial intelligence, machine learning, this is definitely a buzzword. It's important. I think even if you don't go for robotics, I would really prefer the students out there who are listening to me, please do include artificial intelligence and machine learning in your degree programs. If you are going to pursue a degree in science, whether it's robotics or not, please do include these 2 courses, artificial intelligence and machine learning, in your degree programs. They are going to be very useful to you in a couple of years' time. Engineering mechanics, since robot is a machine, it will have some moving parts, and that the concept of machine design, gears and pulleys, how they are working in sync with one another, this will be taught you through engineering mechanics. Now, once you study this first 8 domains, then the later 4 domains will be the specializations. Robot machine design, which deals specifically with the design of machines and mechanical side. Robot systems development, the overall combination and integration of hardware with software, the integration of electronics with the computer program, and their integration with the mechanical side. This is robot system development. So it's basically the integration of all those 4 modules. The automation and control systems, how can you use a particular robotic system for the automation of an industrial process control automations, and of course, perception. Your robot should be able to interact with the environment. It should be able to know its surroundings. And that comes from if the robot is equipped with instruments and sensors that are able to learn the surroundings. Image processing is one of the parts of it. Okay, now I'm going to come towards the administrative parts. I'm pretty much done with the technical parts of the degree program. Eligibility criteria, you should have at least 60% in your metric or O levels, at least 50% in your high secondary. And definitely you must have mathematics at high secondary level. This whole criteria forms the eligibility, makes you eligible to apply for this degree program. Okay. Now, generally, if not considering the COVID is basically a hardship, COVID की वजह से काफी hardship cases हुए हैं, the exams have been delayed. तो definitely उसमें है, but generally our criteria, selection criteria is we conclude 50% marks of intermediate, 50% marks in the admission test. And if your intermediate marks are not available, then matriculation marks. Current जो भी है वो आपको हमारी वेबसाइट से इस वक्त बहुत easily मिल जाएगा, whatever due to COVID, whatever the admission criteria we are following over there. For O levels and A levels, a detailed criteria is also written over there. Now, if you do not want to follow the admission test, then we also offer admission on the basis of NTS NAT. There is a cutoff, set cutoff, and your marks should be higher than that. If not NTS, you can also come via the SATs. And you should have SAT 1 and SAT 2. In SAT 1, you should have 1,000 or more marks. In SAT 2, you should have 550 marks. Math level 2C is a must. Okay. Now, if you select the NU admission test for BSEE, BS Robotics, same goes, BS IoT, Internet of Things, your entry test will comprise of 10% English. And yes, engineering का है, but ये robotics के लिए भी यही है, IoT के लिए भी यही है. You will have 10% of your entry test will be allocated to English. The analytical and reasoning skills will be allocated 20%. The basic math will be allocated 20%. Advanced maths will be allocated 40%, and physics will be allocated 10%. Together, this makes 100%. आपका पूरा entry test में ये सारे components होंगे. Modes of assessment. Now, once and inshallah, if you get induced in this degree program, FAST is very keen on the assessments. All right, because we need to make sure that our students get the best attention and they learn the concepts, they get the desired learning outcomes. Throughout the semester, we get 2 midterm exams, they're also known as the sessional exams, and 1 final exam is conducted at the end of the semester. During the classes, you will be subjected to quizzes, which are tests, and they would be unannounced, could be. And there are also assignments. Now, these are submittable assignments. Now, the submissible assignments, these assignments could be on hard form. They would have to be submitted in a hard form, or they could be in the soft form. They could be some project. All right. Apart from that, because our main focus is on enhancing or harnessing the psychomotor skills of our students, so they can get the ability to perform a particular experiment, so they get the ability to use the equipment and to get the desired output. We follow, in this particular degree program, we will follow extensive project work, and hands-on demonstrations will be required. Labs will be allocated. Every course will have a specific lab session. So the 3 credit hours ka theory course hoga, there will be 1 credit hour allocated specifically for the lab. Every week you will have a lab session where you will go and you will have some experiments, some problem statement, which will be allocated to you by your lab instructor. And by the end of that 2 to 3 hour session, you will be required to fulfill the desired objectives by constructing some device. Could be an electronic in nature, could be a computer program, could be a robotic device. But definitely that would be methodical. Pehle semester mein to nahi aise hoga, but as you progress, as your learning curve increases, your problem complications, the complexity of your problems will also tend to rise. Now, in our Department of Electrical Engineering, where this degree program is currently would be housed, we have 11 dedicated labs. Okay, and it's shown in front of you. We have a lab dedicated for microelectronics, small signal electronics. We have a lab specifically for control systems, for embedded systems. One lab is specifically for final year students where they can come and work on their big final year complex problems. Okay. Then we have one lab specifically dedicated for microprocessor interfacing and microcontroller programming. We have an engineering workshop. We have an operational circuits lab. We have an electromechanical systems lab where you will get hands-on experience of motors, generators, and how can those motors and different sorts of motors and how can they be used in your robotic systems. Then apart from number 1, where you had, I specifically said microelectronics lab where small signal electronics is taught. Then we have a high power electronics lab where devices or applications where high power is needed and the electronics related to it is taught. We have a telecommunications lab. Definitely, if you need to operate a device from a remote position remotely, you need to have some wireless communication modules. So communication lab is there. We have engineering computer labs, and this is CS Lab 5. It's divided in two parts. So pretty much we have two labs, 5A and 5B. Each lab is equipped with modern computers and softwares, and those softwares which are not readily available, which are not even installed in there, they can be available. We have a very active IT department which can arrange any software needed. And finally, we have the power systems lab. Okay, so this pretty much brings me to the, we're drawing closer to the conclusion. Go ahead and please apply for the BS Robotics program. The last date of application submission is 30th June. The admission tests have already been initiated from 21 June onwards. The declaration of qualified candidates would be starting from 5th July. The interviews for financial aid applicants, and we do offer that, that is yet to be announced. Admission formalities, the fee payment or the clearances or the document submission, that can be done between 5 to 12 July. And commencement of classes will be announced. Please stay tuned to our website, and all of these details will be updated over there. Now, coming to our faculty, the faculty which will be responsible for teaching you the BS Robotics. We have 3 professors with PhDs, 3 full professors. We have 14 assistant professors. 3 of them have PhDs, and the remainder 11 assistant professors with master's degree from premier universities, local and international premier universities. We have 6 lectures, all of them equipped with a master's degree from premier universities abroad and local. And then we have 5 lab engineers. These lab instructors are dedicated in every lab, okay, and they are always present there to help out the students. Now, to show a couple of achievements of our FYP teams. FYP stands for final year projects. This is a project statement that our students get. And of course, this is from the past years when we had electrical engineering. But what I want to show you here, that our department is already very well versed and very experienced in conducting and advising FYPs related to intelligent machines and robotics. So if you see the list of these, I won't be able to say all of these names, but we have worked explicitly in the field of robotics, machine design, intelligent machines, biomedical applications, robots, cruise control systems for automated vehicles. And these projects have not only been accomplished, but they have actually won several competitions. And some of these main competitions, and all of these are national level competitions. Our university students have represented FAST NU using these projects, and they have won glory and laurels for our university. Now, here are some other projects. So we're not only, into this, we have also won several government funded prize monies, government funds, NGIRI, ICT R&D fund, all of these 9 projects. And these are like from the past 2 or 3 years. All of these projects have won some set amount of government funding. Now, you can say that this is not a lot of amount, but our focus here is to come up with cost-effective manners. And to maintain professional ethics, we only demand as much as is needed. And we try to come up with our solution, our technical solution, by setting ourselves within these price limits. Okay. So the department has a very strong industrial academia linkage. We get on-campus recruitment drives almost every week, very regularly. The department often conducts industrial tours. We have our placement office, a dedicated set of professionals who continuously interact with high-profile employers, both national and international, and they send out CVs on the behalf of students and arrange interviews and recruitment drives. We conduct final year project exhibitions, open houses, exhibitions and competitions very regularly to instill a sense of competition amongst our students. We conduct seminars and workshops for the training of our faculty as well as for the students. This definitely increases a sense of networking between the academia and the industry. And we also arrange mock interviews. And this is to teach our students the conduct, that particular objective that I discussed earlier. Okay, so I've discussed this project competitions part, and In the past, our graduates have been placed in all of these big universities, DESCON, NESPARC. Most of these industries offer automation specializations as well. We also get internship opportunities from many industries. Some of them are shown over here. And then almost regularly, our students, after graduating, they get placed in Ivy League, international and foreign universities. Some of them get even full funding or at least partial funding in all of these universities. And most of these universities are really the best in the business.